Now I'm going to bring your attention to, we are not discussing the technology yet. We're looking at the library searches versus, how the search engine searches work. Libraries are closed environments in terms of how they are set and the technology that runs within its databases or its servers. And a lot of libraries are connected through VPN with their branch offices, as well as connected through APIs. We call it, these are the kind of interfaces which allow the other databases that are outside of the boundaries of that domain to connect and somehow allow for the information to be exchanged. And this happens through the internetworks, which only works as a communication wires, which are pretty much set as point-to-point connectivity without any disturbance of having influence of you as a user to get to rest of the internet environment. So basically, it's a kind of a connectivity that uses internet wires to connect with others, either through VPNs or through APIs. Okay, you don't have to worry about APIs. APIs are just middleware. We call it middleware in the programming language because it has the ability to parse data from one platform to another that may have different technologies running, technologies in sense of the softwares and other applications, or could be different operating systems. But that's what the middleware is about. So it allows connectivity. Now, in the libraries, as you can see with this chart, that there are certain arguments which is for the librarians to argue that internet does not have all the information and it doesn't have reliable or credible information, or it has all sorts of things which they can defend to somehow make a case that library environment has more information that you can use to do your research versus just finding bits of information that are scattered all over the web. So this is the argument they make. But let's just look at it, a little bit more from the perspective of how the libraries are set. And you would know why these arguments are valid from the librarian side. And then again, from those who are using internet as their primary resource for collecting information. So the argument that is coming from librarians, they're saying everything is not in the internet is not organized, no quality control, difficult to find information, and so on. Not all printed material or digitized books, journals, magazines, etc. are electronically archived. Obviously, I mean, there are like millions of books out there, and not all of these, especially the ones that are in printed format, they are not digitized yet. And the libraries are making that extraordinary effort to put as many of them in a digitized format as they can. So obviously librarians are doing that job, and for that reason they have those kind of material. From the perspective of those who use internet, they say it has more current information. Database search is easier, easy to cross-reference, easy to copy-paste, easy to download. Some of the, some of the information is secure and encrypted, especially in deep web. Easy to update information, inexpensive to own, and so on. So these arguments are there. in a way, you could say that somehow whatever the deficiencies are in the library system can be compensated by the internet, and likewise, whatever information a user requires that needs the library's environment, they cannot do without it. So they could still be incomplete if you are just relying on the internet. So it is a give and take, and researchers obviously have to use both information sets. Now, in the libraries, you could see that you, supposing as an online information researcher, has to connect, like in Library of Congress, like Mark was mentioning. So you have to enter into their database. I believe you must have registered, or maybe it is open to public, I don't know. But let's suppose their database is in-house, which means that they have a system that has a different technology running, and could be the kind of database that is using some database applications like SAPs, maybe MySQL or whatever it may be, and then they run their own programs, which is somewhat similar to the search engines, textual database search, and that's an improvisation, really, to be able to find, or for letting the users find that information which is in textual format to work similar to the search engine. But those algorithms and that database itself is actually not what we call the indexing system, or the system with which the internet search engines work. So it is the kind of search that would allow you to find digital formats like e-books, e-magazines, and so on. Some of the books that are already digitized will be there, but it won't be complete, because considering that it takes so much more effort to, to, first of all, it's a process, and it is a kind of a skill and a technology involved, which makes the digitizing of individual books and their pages to be captured and then organized itself is an exercise which would take time and effort, and it would just keep going on for years to come. And that's how you would find somewhat certain documents that are accessible through digitized format and through the searches internally, which Mark was referring to. And why they're different is because this database that the library system is running is separate or different from the indexing system or the database of web pages, which is using the HTTPS protocol. And all that internet is going to do for you as a user, for you to search in library environments, is that it is going to give you only the access up until the web page that you are accessing for that library, and until you log in or you register, that would authenticate if it is secure system. If not, the public access is also possible, but it is only through the internet. So internet would work as a vehicle, as a connectivity link only. So when you're doing searches in Google, you are only going to find the information that is either captured by the search engine, because in case of what Mark was looking for, it could be a piece of information that somebody used as a reference or someone uploaded, or maybe the library thought that it is more of a public information, so it did not secure that page. Or if that page somehow was copied and used as a reference or piece of information that made its way into the indexing system of a search engine. So that's why it was able to find that. Now, what Mark was saying and what I couldn't understand, where Mark, you mentioned, I'll just open up your, you're able to see my screen, eh? All of you, right?
Yes.
Okay. Let's just look at, so Mark, so far, did you get any clue of what was the ambiguity or somewhat brings an answer to your question somewhat?
Well,
now this you there, Mark?
Yeah, I'm here. You know, see, really what I'm trying to just get straight in my head is obviously whatever pages are indexed from the Library of Congress, you know, using a Google search is one thing. However, I tried matching up some of the results, and you know, there are similar results between me just going onto the library site and doing the Google search. But my question is, what happens if there's information that, for example, has not been indexed, such as like those no follow links that are listed on the Library of Congress's site that obviously would not come up in Google search. So it's really, where's the information? Where it's basically what I think it's coming down to is I would have to do a search using Google and the library's own data search engine to be able to come up with the most comprehensive results, is what I'm thinking.
Exactly. So you answered it absolutely in the right way. Like I said, that there are arguments, and started with that only so that you understand that when you're doing a research, you don't rely on internet alone. You can also go to the libraries, archives, and search over there as well, and grab those information pieces. Now, there are certain researches, it depends on the objective of your research, the depth of your research. If you require a data that has to have enough credibility that you can actually make a case of bringing a data that is already verified through perhaps references, citations, or if there is some way of for you to verify certain facts that are presented on the internet, and you want to cross-check it by going into the libraries and finding more about it, then this is what you ought to do, is exactly what you did, is that some pieces you collect from the internet, and the others you can find more in-depth and more detail of that in the library environment. So that's how you do your research, you know, not to just depend on because the internet is voluntary submission of information. It is really mainly more effective for doing quick searches. Like I said, not all the books that are in printed format in libraries are digitized. So you may not find all of them, but at least you'll find some of them. And then on the internet, you could find quick facts. You can find up-to-date information. I guess, you know, other things are like articles, you know, some of the accessible online databases that are that require subscription, so you can do that. So all that is there, but not everything is available on the internet. Besides, you can't find free information or books as you do in library that are massive or that have a lot of volume to it, that you know, get uploaded. Because whenever you put something in a public domain, then there is always a IP issues, you know, copyright issues. Whereas in library environments, it isn't really specifically stopping you from reading or using that information unless you republish it in any way. There is a legal aspect of it, and that way you don't, you know, just publish unauthorized distribution of electronic books that you put on the internet or share with anybody, and you might just get sued for that. So there is legalities involved as well. Anyway, so this was the answer to that. Now I'll start with the, so Mark, now you know, eh?
Yeah, thank you very much. I appreciate you, going through this process with me during the class. It was very helpful.
Right. Sure, especially if it's clear. What makes it better is when you're clear about it. If you're not, you can still ask, and there could be arguments which I don't mind, dealing with. But for now, I think we will get a better understanding of how the internet works, and that way, it'll just give you even more answers to anything that's left out. So let's just look at this chart. Actually, with the internet technology, we don't expect you to have an IT background. The idea, or I guess one of the ways in which we have explained it in the book, is to make it easy and simpler for just anyone to comprehend without dealing with the complexities. But more of it has to do with your logic and your general understanding or visualizing few things, not that you will be tested as someone who understands the technology in the deeper layers, but from the surface of it, as a common user, you should be able to somehow follow it. And if you don't, you can ask questions. But let me finish this subject first, or say that when I get done with this slide, then I will ask if you have any questions. So let's just continue with the flow for now. And I'm going to show you this example. This is pretty much like a network diagram. So, I mean, there is no other easy way to explain it. But don't worry about all the numbers here and things like routers and PC1, PC2 and all that. Just follow the arrow, and without worrying about what's on the right hand side. So let's start with the left hand side. Let's start with networks. So how the internet works, or the technology itself, is basically starting with the communication links. So anything or any sort of communication that happens either wirelessly or with wires, those are just hardwares, or you could say that transmission lines. And for that reason, I don't want you to worry about how the transmission works at this point. Just think about how the devices communicate with each other. So from the network's perspective, we're strictly talking about how these network devices are connected and what is included in network devices. Network devices communicate with each other, and they do it in a closed environment, in a confined space, or they open up more where two confined spaces communicate with each other. And as they expand further and more network environments start to talk to each other, they sort of create an internet environment. Internet, or the word itself, internetworks, is the same thing, which means that it's a collection of networks which happen to be able to talk to each other through the devices. And there could be different devices. One device is used to make the connectivity possible between lines, and the others are the individual, you could say, the internet devices like smartphones, PCs, whatever you have, how those devices talk to each other. So that is the idea. Now, in here on the left hand side, you could see that this is a small environment of a small network inside of a home. And the home networks is connecting all those devices you're running inside of your home, wirelessly or with wire, doesn't matter, but it is done through a router. A router means that it routes, or it connects and tells which devices need to talk to the other device, or for one device to be able to communicate with the next device inside of your home would have to go through the router. So router is not only communicating from outside by connecting to your network provider or internet provider, but is also responsible for communication between your devices that are linked together inside of a environment like your home. So this is a small network of your home. When home network grows and it becomes a town network on the left hand side, the town network means that these could be government buildings which are connected to the together. It could be branch offices. It could be someone sitting in any town that wants to connect with their home PC. So that sort of extends and expands the network. And the only way that you're connecting from town or your office to your home is through the internet. So the idea is that when the networks expand, they expand into internets, and internet again comes to the office environment, so that the office where the small office is running their own internal networks similar to your home right here, that that office network communicates with through the internet to your home devices. Okay. So whatever is shown here as a cloud, it's just giving you, when we say cloud, it just means it's a lot of wires and lot of wireless connections that are talking to each other, and therefore this cloud is called the internet cloud. Likewise, the city grows from town and becomes a bigger, larger network. And so it's a combination of networks. They start to talk to other networks. One network would communicate with another, and so another, and it goes on. But the way they connect with all of them is through the internet. Okay. And the players that are there who actually, I would consider them in two respects. One of them is the bandwidth providers, or those that own the communication lines. For instance, Bell in Canada, Bell Canada. In US, it's AT&T, and so on. So those people actually have been there for ages, and they own the infrastructure. They own portions, or they have invested in satellites. They've invested in broadcasting antennas. So all the hardware that is responsible for delivering or communicating through the internet network is owned by these large corporations. And we call them bandwidth providers, or they are the ones that would give you, well, let's just leave it there for now. Now, the next part is that of the ISPs, which are slightly different, or you could say that ISPs are the internet service providers. At times, even those big companies like AT&T and Bell have started to provide extra bit of services similar to ISPs. So they are sort of growing from what the ISP is about by adding more services to their offerings that goes beyond bandwidth provision. So what is ISP? Internet service providers, are the people who actually use the companies like AT&T or bandwidth providers by having large pipes that run into their environments. And in turn, what they have in their platforms as ISPs is bunch of servers, or we call it a server farm, that holds websites, or where the websites sit, where the website are hosted. Websites actually are given a domain name by yet another authority. Those authorities are called domain registrars. And a lot of times ISPs themselves have under contract became responsible for holding domains, for selling domains, and so on. The idea of ISP is to have a one-stop shop where a website can be hosted, it can be managed, enough bandwidth can be provided for those websites to become visible on the internet. The hardware itself has got a lot of different technologies running in them, which is very difficult for any common person um, to put or to stage on their own servers. Therefore, that service of maintaining and the technology that holds those websites are managed totally by the service providers or ISPs. So mostly when the search engine has bots or crawlers or robots that run into the domains and then to find those pages, they have to look for the websites where the website is hosted. And definitely the only place that, or the majority of the websites are held inside of ISP environment. So they crawl into the ISPs and they look for all the hosted websites attached to the domains and collect pages. So that collection process, it just keeps going on 24/7 and at a very lightning speed, like those robots are crawling all across the ISPs. By the way, just for your information, there are certain companies and certain environments that have secure servers or for which they need a specialized team to manage those servers. They hold it outside the ISP environments to lessen the risk in different ways, because ISPs, when they provide you those services by staging your websites, have something they call SLAs or service level agreements. And those service level agreements are not foolproof. And at the same time, it is a little bit complacent as far as the liabilities are concerned towards the users or towards the owners of those websites. And there is always a margin of error, and the disclaimers sort of makes it slightly unreliable. So for that reason, there are companies, there are especially financial institutions, they have their own data centers. They don't go with the ISP services. So this is outside of what we are discussing, but for your information only. So let's just stick to ISPs right now. Now, anything that is to be discovered on the internet eventually through the browser is going to tap into the indexes of search engines, which are separate from ISPs. So ISPs, even though they are responsible for staging those websites and for the web pages to become visible, those pages are not queried directly when you do your search using, for instance, Chrome browser. Chrome is not going to the ISP. Chrome is going to take you to the search engine environment, which I'm going to explain in the next slide. So for now, just think that ISPs are connected through routers, and different ISPs communicate with each other because no ISP can work in isolation. Internet is an interconnected environment. Nothing in the internet works in isolation. In order for the pages to become visible and for the browsers to give access and for bringing those pages to the users, it has to be, so this is the information that has to be exchanged across the platforms and across the different ISPs. So as you could see here, routers are responsible for those kind of connectivities, and we are not concerned about how the routers work at this point. And even in the book, I don't want you to pay a lot of attention to what how the routers function, because there is a bit of extra information. In my opinion, it doesn't belong there, because it first of all, it won't come in the exam. Second of all, it is for your information only, for as much as you want to know, and you can learn even more outside of the book. So that's just just the kind of information that I'm letting you know whichever points or whichever part I don't emphasize on, and you still see it in the book, it's probably not as important. But I mean, it depends on your interest. Anyway, so these are the ISPs. Now, rest of it, as you could see on the right-hand side, is not as relevant. So we are not going to worry about it. We are not learning about things like, how it's just showing you, it's a common sense chart. If you look closely, what you see is the routers connecting ISPs giving access to, information pages that are accessed in the office. There is modem here. We don't want to know what modem is about. Servers, you all know what servers are. Does any one of you know or would give me an idea of what is the difference between a server and a PC, or let's say your laptop, anything else that you're using? What do you think of a server? Why do we call a machine a server versus a PC? A server can have a box, can be about this big, and replicate something exactly the same with the same dimension and similar hardware would be called a PC or a desktop. But there is a difference between the two. Because I'll keep using the word server, PC or a single piece of desktop is not of interest to us, because we are just discussing internet, and servers is a term we'll be using extensively. We won't find a mention of desktop as much. Do you know what servers are? At least you have a common idea. You have a, just an idea, right?
Well, server,
Because I don't want to.
a server, depending upon, what you're using it for. Obviously, if you're in home, you're using your laptop or PC, and everything is getting stored on the PC. All the applications are on the PC. If you're in an office setting, generally you're having files stored up in network folders on the server, and some of the applications could be in the cloud, so to speak, that you're accessing on the server. And the server has different functions. It could be a print server, it could be an internet server, file server, et cetera, et cetera.
Got it. So now that is Mark, eh? Was it Mark?
Yes.
Okay, so Mark explained it correctly. I didn't have to. So this is what server is. One more thing, Mark, there is, now you talked about how the server is used in the office environment. But when it comes to ISPs, the function of a server changes totally. The servers in the ISP environments are using a different kind of operating system, and it's using something called a 3-tier configuration, which means that it has a portion in the operating system which is responsible for managing the application or the website itself, like the web pages. Then you have a portion of it that is going to be dealing with the database, or it's called a database server. And then you've got a web server. So web server is the secure part, or where your website is using HTTPS. Application is where you have certain softwares or certain other applications that are downloadable or that are visible on your site. And then you've got a third layer, which is a database. All three layers are kept separate in a virtual way because the security settings on all three of them are different. And the most secure part is the database, which basically is a portion that separates or kind of has a function that is called through the programs that run on that server, including the web server. So it is that's why it's called 3-tiered configuration. And that's why this server is different and somewhat has a unique technologies that would do load balancing, that would do database optimization as it grows and so on. Anyways, apart from that, let's go to the next one. This one is going to talk about the search engines, and it is also going to talk about the ISPs. Let's start with what we have on the left hand side. You could see these numbers 1, 2, and 3. What it's just telling you is that there are two kind of applications that run on your desktop. There is a web applications. Web application means that these applications are basically accessed through the cloud or through the internet, where the machine that you are running it on is using a browser or a browser environment, basically, to be able to bring that or make it visible or make it usable. And that browser could be any browser. It doesn't have to be Chrome, it could be any browser. So only those applications that you can run using a browser or web application, while there are others that you actually end up downloading through the browser, but you have to install them on your local machine so that they run in a native mode or in a local mode. Those applications are called local applications. Or you can simply use a CD or any other previously used mediums to install your local applications. You can do that also. Those are local applications. So the web applications are the ones that are this is the distinction. So you have to know the difference between web and local. That's just a terminology that you need to understand. Now, in the fourth one, I am pointing to something called internet bandwidth providers like AT&T. That's responsible for connectivity. Even the AT&T is actually providing the physical connection or the physical circuit to the environment. Now these circles are environment. Environment 5 is mentioning about the ISPs, which could be, let's say, companies like GoDaddy, like Yahoo Hosting, Host Excellence, and these are some of the examples of ISP. So all of these ISPs are getting their pipes and bandwidths through the through the bandwidth providers, as in 4. But what is happening in the 6th one, or this circle, is where we are accessing the indexes of web pages. And those web pages are accessed, let's say, through web applications right here. So web applications are, so like browser is one of the web applications. So the browser is accessing the pages through the servers or from the servers that are held in physical locations that we call data centers. Data centers like Google has thousands of high-powered servers that are responsible for collecting and indexing pages. What the Google environment or the data center is doing all the time is sending its robots into the ISPs, and ISPs are giving free access to those web pages through their browsers, recognizing the boats that are called friendly boats, or the boats which has a certain DNA that is acceptable by the ISPs to allow them to open up and give access to those websites. So those websites has web pages that keeps getting collected, and they keep building the indexes of these data centers. And data centers are spread all across the globe. For the Google data centers, you can count on the fact that depending on the geographic location of where you are surfing or using the Chrome, it would find those pages or access those pages from the nearest data center of Google. And that nearest data center is basically all performing two functions besides indexing the pages. It is what they call cluster. It is using a clustering technology, which allows for that specific data center to accept or replicate its index instantaneously as it is collecting it from, let's say, a local ISP, and those pages are being indexed in, let's say, data center A, which is closest to the user that I'm referring to. Now that data center, while it is collecting and indexing those pages, is also replicating that page and sort of pushing it to the next closest data center. So basically there are hops and hoops all across for all those data centers to simultaneously be connected and perform clustering and spreading of that indexes in a manner that replicates everything and consistently delivers it, so that there is a uniformity, and that's how it is sort of set. So you are accessing it through the data centers of Google. Now this is all that you need to know as far as the technology is concerned to how the internets perform or connect, but how it is now going to the next step, the indexing part. I'm not going to do this one. This is about the browser itself. I don't know if you know, but generally the concept of a browser and search engine is mixed, or it's somehow gives a notion that the browser itself is a search engine. Browser is just a program. It's just a localized program that is sitting on your computer. It can only occupy so much space, and it has only so many lines of code. So for as much as it is collecting a lot of your history and other information, it is still very limited number of it has a very limited megabits or limited space to be able to perform or to index, or to keep that large of an index. So basically what it is doing, it's just that it is a communication link. It is providing a sort of a pathway, or it is establishing a point-to-point connection, more like a VPN, to the data centers. And the performance of the browser itself is limited to collecting I don't know how to put it, but collecting certain portions of information from the users behavior and history, as well as allowing you to do some of the adjustments, or you could so to say that it has a browser adjustments that it allows you to do, but all the functioning and everything that gets performed through the navigations and buttons and utilities attached to the browser are being executed on the server side or on the data center search engine area. And so the browser model is of a native client or a native application, and this slide is just giving you an example through these three layers, which is mentioned, just mentioned, not to go into much detail. Like A is the interface, which is the query area, and a box right here. Then you got a B area, which is the output of results, which means where you are receiving the results. But in the middle portion, they have mentioned, or it says that there are certain technologies running. One of them is called rendering engine. That is important. Rendering engine is where the computation happens, or where the decisions are made, and that logic that is really the brains of the browser itself. This portion or this part is called rendering engine. Rendering is just putting everything together. Anything that you are seeing that is returned back to you as a web page is coming through the rendering engine. That means it is collecting information in HTML format, and then it is basically projecting it as a user, similar to how HTML is responsible for making the users see the page in the format it's shown. So this is what rendering does, is just collecting the information back that is coming as HTML codes and then returning it and making it visible. So rendering engine is important. Nothing else you have to worry about. This could be the only question, if at all it shows up in the exam. Next is the robots or bots or crawlers. Now, robots are really small applications or programs that when we say robots are running all across the networks, as if they're going out there and just collecting pages, but there is a technology involved in this, which means that these programs are doing something we call cron jobs. Cron job means that it is a repetitive action. It is like a bullet that you're firing in an auto. Once one bullet goes, the other one comes in and it gets ready, except that it is more like a machine gun. So it is repetitive firing. And those are the programs that has IP addresses, or they cover certain regions, that are responsible to look for and find and attach and basically pull those pages back for the servers. And it has a preference, like it would just go and query and bring pages that are coming from the sites that has a content which is fresher, or it just is known for the kind of content that changes rapidly or frequently changes. So it gives a preference to those websites. In our case, for example, if we are publishing articles and our articles are updated on regular basis, more than likely the Google will have a preference to come to our website versus that of our competitor, whose content is stale or is not as frequently changed. So that kind of a decision, it has a bit of an intelligence, it has a bit of a direction, and it has the ability to capture and bring those pages back in a format which gets rendered into the browser, and browser then produces it or presents it to you. Anyway, so these are so what it's doing, it's collecting pages. How it is collecting pages is, for example, in this domain like airsassociation.org, it's going to go to its sitemap. Sitemap is what will describe all the pages that are connected inside of that domain or on that website. Any page that has HTTP link that is part of our domain or main domain is going to be queried, is going to be looked at individually before it is captured. And they'll just keep doing that over and over. So this is what this link is showing. So for instance, it went to About AOFIRS page. This link itself, if it is it's a dynamic, it has been changing often. It is going to pull this page About AOFIRS and bring it and archive that consistently. This is just giving you an idea of how the index is captured. So anything that is crawled onto the site's sitemap is getting indexed. Like A would be the, let's suppose A is the main navigation, and the main navigation has a small page, a sub navigation, another small a. It has, then it's going to start to make copies. I mean, this is a silly diagram. In my opinion, really, it's, I mean, there could be better diagrams, and the process that you're looking at is nothing but collecting pages and sub pages and sub navigations. So it is not really as important, just so that you understand how the robots work and what is their function. That's all you need to know. Here I have a slide that's talking about the database of a search engine or the index itself. The index is it's designed differently. And the reason you're looking at this chart is because it is in comparison to RDBMS or relational database, which is typically a kind of database that we are used to using or is used more often in office environments. Even till today, like most of the programs that are built using RDBMS. RDBMS can be MySQL, all the local database, SQL, Oracle, what else is there, whatever those even what's that, Microsoft Access, all of these databases are RDBMS, or relational databases, which means it is organized to capture different attributes of a same record. I'm just relating it, or just giving you a general idea, because I'm not teaching the databases. So the idea that you can visualize is that you have to think of a spreadsheet or an Excel sheet, and it has rows and columns, and you can think of each row to have a name that identifies it or gives it a reference, and then each block of information you can think of it as a field. The column or the heading on the column could be the name of the attributes. Okay, so let's suppose that it is easier for me to locate a record when I say B6. So the line 6 and the column B, that is how we are used to capturing or accessing the data. And this is pretty much similar to how the databases work. To find that particular record or that data field, you just capture it by giving references. But in the textual database, it is very difficult to put each of those words in columns and rows. So it is not only difficult to just find one record, because it is not just the record itself, but it is an isolation of a word which wouldn't be able to connect with any other word, or the sense in which the words are combined cannot be interpreted. So this is where the indexing system uses a different kind of database, which is where each of those words are considered individual data fields, and those data fields talk to each other or communicate with each other or build relationship with each other, except that this relationship is of records that are mix of words, and all those mixes of words have to be called not through the record number as in typical database, not through giving just the reference in terms of where it's located, but rather to build the search in a way that it starts to make sense out of combination of words. So in a mixed bag of words, a word can be in the second line as in the row, and maybe second line, and then the column can be 6 or B column, yet it needs to be connected to another word which could be down here on another side, but it needs to be done in such a way that it makes a linguistic sense, or it is not something which is which cannot define the expression as in in whatever language it may be. So in this document or in this title, let's say there is a record which is talking about a student, Mark Anthony, gender, course, and location. Maybe these are the fields or these are the information types that needs to be collected with reference to keywords or with reference to any other way of how it needs to be. It needs to be captured, or it needs to be searched. So not to now this scenario is just saying that all this information in the document title has to make sense for the search to find, and if this information is to be collected through a typical database, then the database would look like this one on the right hand side. As I was just mentioning, I didn't know the slide was here. I could have made made it easier for all of you. So let's suppose a typical database has a record number or something in the first row that says 1019. If I have to pull this record, I would be able to pull the name Mark Anthony, or from the name Mark Anthony, I could also pull other attributes, as in column D, it's talking about location. So Mark Anthony, I want to find, and I want to find the location. I can find that because now it has made a thread. It is a relationship that is built through using any of these attributes, or any one of them will connect with the rest of the information. So it has a relationship. Whereas in the indexing system, this relationship is not possible, because assuming that these were different words, and if there is a combination of words between, let's say, the word C and D, it could make sense for finding something, whereas connecting, let's say, a word in E, in field E, would also be able to connect with C, only the meaning will change. So just because linguistics is the kind of a barrier which makes it difficult for the typical database to interpret, and for it to organize it in this way, it is going to use an indexing system. An indexing system is just going to look at, as I mentioned to you in the previous slide, it's going to look at bunch of words instead, and not as individual attributes like name, gender, and so on, put inside of the individual data fields. So this is the major difference. Next thing is the communication between two devices in the internet. Internet devices are, well, something that's not mentioned in here, but let me give you an idea. I don't know if you know, but in any device that you use on wherever you are, it could be their mobile phones, or it could be your desktop, or whatever it may be, it has the communication card, something we used to call NIC card. Now that NIC card, or a network card that is responsible to connect with the bandwidth or wireless or the wires, is got a number, or it has an ID that is embedded in its hardware as well as written on the board, that we call MAC address. MAC address is the one that is going to tell, or would have the information that says that this card was actually inserted in this device, or it could be the phone, and the phone has a serial number. That serial number is in turn connected with the model numbers and the production line, and all the DNA is there to basically, as soon as you are able to identify the MAC address, you know who the phone is sold to. Not that where it is used, but at least it identifies or takes you to the owner of that phone, for example. Then there is another thing that runs inside of these devices, and that is a GPS, or global navigational chip, originally invented by Garmin, and that chip is in all the network devices these days, even in the routers, in the whatever thing that you have, even the watches that has internet access now, they have this device. So that is a tracking device. Then there is a network which wants to know who is using its bandwidth, and where it is registered, or where it is being accessed, and those are called IP address, or internet protocol addresses. IP and TCP IP, or IP/TCP, those are the two protocols or the naming conventions that are identified with numbers, or it has a mix of numbers that are oriented in a way that it has sort of a control on how the numbers are set, and those numbers are set as something that cannot be created internally, but rather it is given out, or it is given as a block of IP addresses by the authorities or the associations that are responsible for giving out those blocks of IP addresses. And there are two types of IP addresses. One is what we call public IPs. Public IPs are given or allotted or allocated to ISPs that, says that you have like so many public IPs that you can use, or these public IPs are identified with your organization or your company. So that is pretty much an identifier of where those IPs needs to be used, or who has the authority to use those IPs. Those are called public IPs. But a lot of times those public IPs are not enough for the ISPs to handle like hundreds of thousands of consumers that are using their services. So what they do is they take one IP address and then subdivide it, or sort of create internally IP addresses that are called non-public or private IP addresses. Those IP addresses are created through or by the public IP, which is going to tell if how many of the private IPs are running under it. Now that itself is a science, and it is more like a method and a methodology which is embedded in your routers that you run inside of your home. Those routers are using what we call private IPs. Private IPs are of two types. One are dynamic and the other one is static IPs. Dynamic IPs keep changing every time you connect with your internet. The static IPs are the ones that the ISPs are, even though those are private, but the ISPs give it to you so that if you have devices that need a consistent connectivity and it is not distracted by automated IP changes, like as in your cameras that you have installed at your home, and you want a consistent access to those, you may ask the ISPs to give you a static IP so that you can all the time be able to look at the, through the view cam. So it is a lot of information for you, I know, but it's not something that is going to be asked or going to be a problem for you when it comes to the exams. In exams, you will be asked if you understand what is public IP and what is private IP, and they will give you, bunch of answers that you have to choose from. It's all multiple choice. By the way, did you all get? Well, let's talk about it. We'll talk about the about the assignment email I sent you. So I'm going to have to see what the header contains. The header that you're seeing is very brief, like this one, for instance. It's not giving a lot of information. So what I would do is I would look at the detailed header by clicking on these three dots, and I would like to see where the view raw message is. So view raw message gives you that access of the details of where the email is coming from. Otherwise, unless you click on this, you won't be able to see that. So when I do this, I see all sorts of information, even the encryption part is showing. So it is something that visually I won't be able to decipher. So what am I going to do? I'm going to use applications like IP2 location email header analyzer. So even if you type email header analyzer, just 3 words, you should be able to see a lot of these websites, and each one of them, I mean, it could just be any header analyzer. and mostly it is in the public domain, you can use it. But my favorite is IP to location. So I'm going to click on this and open up. It is an interface that would allow me to put in this area the entire script of this header, which I'm going to copy. It's a long one. So now I have the entire header that I've highlighted. I'm going to copy this and place it in the header, email header analyzer like this. And then I'm going to click lookup. Let's see what it's going to give me. It's going to give me a detail of where it originated. And then there are IP addresses. See these IP addresses right here? These have to be identified either as public or private. And these IP addresses are also ranked as reliable or as a spammer, because all of these IP addresses are connected to or identified with the servers that are used either as spammers or as relay centers for email. And that reputation or that sort of rating of how it is ranked is possible for someone to figure out, because there is a huge database available. There are sites like Talos, for example, that would do that for you. So for now, let's suppose that this is the detail I got. And yeah, it's not as detailed. Why is it not showing me more? Anyway, so here is the header itself. And these are the IP addresses that you look at. So the IP addresses that starts with 10 and 10.68.125, these are known as private IP addresses. Private IP addresses are unique in the sense that they're numbers that are presented with the dots in between, and these individually are called octates. So we've got like 1, 2, 3, 4 octates, and each of these octates are capable of holding 3 numbers that should not exceed the digit 255. So the maximum that each of these would have 255, 255, 255, and so on. But then the private IPs are identified by the pool of, or typically how they are numbered. And because they start with 10.68, we know these are private IPs. Public IPs can be 64.18. So anything above that is considered public. So these are identified as public IPs. The IP checker would like you to collect these IP addresses and then insert them in those checkers, and that would reveal the location of where it is coming from. If it is the Google server, or if it is any other server, it's going to identify that. And it is also responsible for pinpointing the location of that ISP or where that server is sitting. Generally, it would give you even more IP addresses that are closest to the ISPs where you are surfing from, or where you are actually browsing your internet. So this is the significance of IP addresses beyond just the communication, or beyond identifying the two devices to be able to communicate with each other. So this is another sort of information that you can get. Besides this, I have another set of information that the email analyzer, like Gaijin, for example, is another tool where you insert everything starts with the raw header. Unless you have the raw header to copy and paste into the analyzer, you won't be able to, identify the IPs because they're not made visible. So anyway, another tool that I want to show you as an example is this one, for instance, where the path of how many servers were in between before the spammer reached out. Because see, what happens is that an email can go from one server that is sitting in one country to another server, which could be another country, eventually masking the origin of it by bringing it to the last length of the IP that could be identified with a legit server like Gmail, for example, from Google. So even though if you backtrack it, you would find that it started from Benin, Port Novo. I don't know where this is. Then it went to another server in Japan, and from there it made its journey from yet another server, because you can see that public IP will keep changing. The numbers at the top will keep changing, and from Japan it eventually went to unknown, and from unknown it took another private IP. So basically what it's saying is that it has something fishy. It is not coming from one specific server, rather it is actually hopping in between different servers, and each of these servers eventually uh, are masking the last leg, or where the last server can be legit, and therefore beyond that you won't be able to retrack it back. So this is one thing. The other thing is that with the last IP address, or the one that is actually shown here, that is bringing it back to the origin, can actually track the location of someone that is using this, or whoever has an account with these people, that can be tracked for the geographic location, or at least the approximate location can be identified. So when I use another application called IP Tracker Online, it is giving me the bearings, it is giving me the longitude and latitude of the origin of where it was used. So here the IP is tracked the location of the ISP. Then we have another application called Talos, for example, that is going to tell if, or give the the legitimacy of that server or reputation of that server, and it is telling that this IP address has got a poor reputation right here. So this is just like going a little bit out of what we're supposed to be learning, and this is more on the investigation side. But because we were dealing with the IP addresses, I thought it could be important. Next thing is that how does the communication take place, or what are the elements or some of the components of data transfers? Data transfers happen in packets. That means that information set that could, let's say, make an image or make an email would come in bits and pieces, because all of that information is not encrypted or placed inside of one long, you could say, packet. So that packet, has to be divided into smaller bits, and those small bits are carrying that information through those pipes or through wireless lines. And once they get to the other side, it gets accumulated and gets reformed. So first it is fragmented, and it is more broken down into smaller packets, and then it travels all the way through the internet. It has embedded information which gives it a destination IP address, and the packet that I'm referring to in the sense of how we have used it in a more simplistic way is shown here, where individual packets have a packet header that is a header. You don't have to go in too much detail, except that the header is something that's going to have a known destination DNA in it, like where it is supposed to travel. IP header has IP addresses in it. It has the information, the data, and then a packet trailer that says that here is where the packet ends. So that, you know, the header of that, or the main IP address, which is what tells the destination, would also know where the packet ends. So the packet trailer is what ends it. An entire package itself is a small piece of information of the whole, and this is carrying everything in it, and it is moving down the pipes. And when we look at this diagram, we generally call it an OSI module, or a model that sort of gives an idea of how the packets travel. So the way the packet is set is that it is gathering information from where the information set is created for it to travel through the pipes. A portion of it carries information about the application, and then there are these different layers of it. It's called session layer, transport layer. So these are nothing but pieces of information, or where the DNA is being created for the partial packet that, together with other packets that completes it, would travel simultaneously in those, through those pipes, and gather more information. As you could see that these rings here are adding up. So each of these each of these layers are of information are adding up, eventually making it into a packet, and then sending it to the other side. When it reaches the other side, it starts to open up, or it starts to bring that information by pieces, putting it together. And then as it goes to the end of it, where the application, here application means it could be a Word file. So your application could be the Microsoft doc, or it could be emails, SMTP, whatever it may be. That application will open up finally, and that information is revealed. So this is how the packet is flowing. And these two computers, PC1 and PC2, are given an IP address, which is what is being carried on this side where the packets have originated. And when the destination is opened up, it is received by the IP address 21.160. So both of these informations on IPs of where the IP is originated and where it's supposed to go is put inside of this little packet. And that's about how we assume, this is how we visualize the movement or the communication happens in the digitized format. This is irrelevant, we've done this one. So basically there isn't much that needs to be covered in the technology side. This must have given you a general idea the entire system, how the internet works and how the information travels. IP addresses, we went a little bit into a zone which was extra piece of information. However, since we are done with the module 1, I'm going to give you an assignment immediately after, which means that for the weekend you will have another set of questions similar to the ones you got, which is 25 of these, I believe, that I gave you. That belongs to the module 2 of CIRS. The module 1 is what you would be able to practice with on the weekend if you like. That's up to you, but it's somewhat preparing you for the final exam. So next, which is the 2 modules that we will address, that has to do with business of research and internet law. How many of you are interested in module 3 and 4 from learning perspective, or if that is useful to you in consideration of your interest, not that if it has anything to do with CIR, it's just your personal view. Any one of you? Okay, so Mark is voted yes. Kelly is saying yes. Warren, we got Daniel. Okay, So we've got the majority vote, and that means that I will expect then you all will be around. Excellent. So that's a good news, because I ask only to learn, there could be some preferences here. I just want to see the interest, and for that reason I'm excited, and I would be more than happy to to get into that. But for now, I also want to inform you, and for you to know that even though we have done a considerable portion of module 2, apparently it's a very big module for the exam, and there are few aspects of it that needs to be covered, which I have left. And not that it's not going to be dealt with, and it's just that we weren't able to complete it, but I will do that on Monday and Tuesday before we start with the business with module 3 and module 4. So for that reason, it seems that I might end up adding a few extra classes, or at least one extra class. And that means that what was supposed to finish up on 24th of September, which is coming week, we may need another few classes the week after, which means that 25th, 26th, like on 27th of September and 28th of September, we might have extra classes, which I have not provisioned for and not yet sent you this new schedule, because it all dependent on when we are coming closer to finishing it. I would look at the inventory and I would know. It seems that for now, it seems that we might need extra classes. So the portion that I'm referring to in module 2, which needs to be covered, I have these slides right here, and I'll just give you an idea of what is left. Internet challenges, info sourcing, data types, and surveys. Now, internet challenges is more on the descriptive side. It is not something which requires a lot of explanation. These are bullet points. Challenges means that we would just, like, half of these, or more than half of these, you and I both know what those challenges are. Whatever is left is, pretty much, understood just by looking at the headings. And if there are any questions for the bullet points in which how I have actually itinerized all of these challenges, you can tell me that you don't understand which one of those you feel that I need to elaborate more on. Filter bubble, we are going to discuss. I guess we've dealt with it slightly while we're doing our search queries, where we need to do our searches beyond just the geographic boundaries, how some of the bias or implied logic from the search engines can become a barrier. Dealt with that to a certain extent. So we will look at what the filter bubble entails and see how we can overcome that. And there is a very interesting talk on this subject in the I'm sure you know of TED Talks. So I'm going to give you a link to that to also see, to get a better understanding. It's a very interesting topic. Then we've got the data types and information sourcing. Information sourcing, I don't want to get into that, because there are like hundreds of different types of internet sources to find information. That includes databases, some specialized searches, the reference books, guides I've given you that has tons of links in it. You might want to consider that as part of sourcing, info sourcing. So it is pretty much more on the reading side, and for you to keep as a reference. So that part we don't have to worry about. Data types and surveys is important for any one of you who has to work with the clients, or where you feel that you need to go independent and look for, or to do some research work for someone. It requires a bit of a knowledge coming from traditional research methods. And data types and surveys is one of the major or key areas of traditional research. And any research reports devoid or not containing identification of your data sources and how you have done your analytics on that data, both on the qualitative and quantitative side, is absolutely crucial, and without it the report is not only incomplete but it could be invalid. Surveys is just methodology of collecting the information, and how you do that online and offline, and what are some of the important processes in doing surveys. Surveys can be of different types and require different approach and a knowledge to create those surveys. Just as an example, it could be just polls that you're collecting. It could be questionnaires you have to build. Could be, qualitative data, which requires for you to create virtual groups, create online experiments, create social experiments, and so on. Focus group is another example. So surveys entails all sorts of information collection methods. That's where what we need to discuss. Then reliability of I'm not going to do this one. Internet information planning, scope and assessment, we're going to touch upon that, because a lot of this where planning is involved for doing your research is covered when we are doing the module 3 that has to do with online business, online research business. That has a bunch of documents that you will be introduced to, and those documents include certain aspects of how you would piece the different process of planning, as well as to create research reports. So for all of that, the planning area gets covered. So I don't want to duplicate something, and therefore the research planning will be covered already by default. Data analysis we'll touch upon. Data analysis, we are not teaching data analytics, so we have to be very careful in knowing the limitations, or say things that we need to intentionally leave out, but still know enough that we could still be called CIRS or researchers that knows their business or knows how to interpret certain information. And that interpretation of information can be either something that involves sentiments, involves opinions, which could be biased or non-biased, how to understand that part. And then the other aspect of it that has to do with the numerics or the data or the collection and information that is definitive in nature, that says yes or no, or gives a very exact scale of answering in terms of numerics. So to create charts and graphs and so on. So only up to that limit or up to that extent we will learn how analytics play a part. Nothing beyond that. If you want to know more about data analytics, I don't know if Eliza, or was it Eliza that is in the there, she's coming from a company that does all of these things. Like she does, I don't know if she's in today. Their company does all kinds of research that collects data online. So I don't know.
I'm here.
Is Eliza there? Am I referring to you correctly? Okay.
Yes, I'm here, but I'm a senior paralegal at a franchisor. So
correct. So there is another Eliza. I think,
Elisa, yeah.
Lisa, I think. I'm sorry, I sort of I don't
No, it's
think
okay.
I've
Our
seen
names
her.
are almost exactly the same.
Almost exactly. And I don't see her attending recently. And I know that she told me she may not be able to attend all the classes, but it seems that I thought maybe she meant like, maybe some of the classes, but it looks like she took that sentence literally as if she's going to disappear on me totally. Anyway, so I didn't see her for a while. So this is just an overview, just to get our bearings straightened out, know where we are heading, what is to come next, because this week has ended, and it's always nice to take a break and take an itinerary of what is left. It is something that would be just assessing. So anyway, I think we are all right. Just quickly, I wanted to see if you or any one of you has any questions so far on what we covered on the technology part. And the second thing I would like to look at quickly and give you a sort of an overview is for the assignment that is sent. So I think we'll just call it a day and wish you a great weekend and in good health, so that I see you all on Monday. And in the meantime, if there is any other question that I can answer, most welcome. Like I said, I won't be able to reply to any emails or any questions over this weekend, please. So I'll see you all on Monday, okay?
Okay,
There
happy
is
weekend.
something in my chat. All right, thank you. Thank you. Bye-bye. Take care.